You may have thought to yourself, why do different instruments or voices sound different from one another, even when they are producing the same note at the same volume? Well, the answer, in short, is because of the instrument or voice's timbre. But the more detailed answer is much, much longer. To answer our question, we first have to ask, what sound is? Sound is a change in pressure, how close or far apart molecules of air are, that travels through the air and vibrates your eardrum. If that change in pressure repeats over and over again, the span of time of the part that's repeating is called the sound's period, and the number of times the pressure change repeats in a certain amount of time is called its frequency. A higher frequency gives a higher pitch sound, and a lower frequency gives you a lower pitch sound. The sound's amplitude is how large the change in pressure is. A larger amplitude gives a louder sound, and a smaller amplitude gives a quieter sound. Sounds can also be added together to make a new sound, with the positive and negative pressure changes at any particular time added together. What's often considered the most basic sound is a sinusoidal or sine wave, due to the fact that a simple harmonic oscillator, or pretty much anything that would continuously move back and forth in a frictionless vacuum, moves sinusoidally, and any two sine waves with the same frequency added together will give you another sound. Because of these properties, any sound can be approximated with the addition of many sine waves of different frequencies and amplitudes. If you graph this with the x-axis as the frequency and the y-axis as the amplitude, you get a Fourier transform. Less tonal sounds, like cymbal, drum, or static, will show many different frequencies at similar amplitudes, but more tonal sounds, like pianos, trumpets, and accordions, will show clear spikes at certain intervals. These intervals will almost always be multiples of a fundamental frequency, called overtones or harmonics. So if you have a fundamental of, say, 110 Hz, you'll get harmonics at 220 Hz, 330 Hz, 440 Hz, and so on. The amplitude of these harmonics is one of the major ways we can differentiate between different sounds. Some other ways that sounds can differ include envelope, which is how quickly the sound increases to its full volume, how long the sound stays at that volume, and how quickly the sound decreases to zero volume. Tremolo, whether or not the sound changes between high and low volumes at a fixed rate. Vibrato, whether or not the sound slightly changes between higher and lower frequencies at a fixed rate. And changes in timbre, like the sound of the player's breath before the tone of the saxophone. Well, that's the end of my explanation. Stay curious.